So for solving trig equations, essentially the strategy in these problems is always get it to a situation where you can get something down to like the sine of x equals a half, or maybe the cosine of x equals -1. Anytime you can get an equation simplified down to some expression like that, your knowledge of the unit circle has to take over, and you say, okay, well, the sine of an angle is equal to a half if that angle has an opposite side of 1 and a hypotenuse of 2. And you think about that angle in here, maybe you think in degrees as 30 degrees or pi over 6 radians. But you just got to remember that that's going to happen again over here on this side of the triangle, or this side of the circle rather, because that vertical component here still has a positive 1. So that reference angle would be pi over 6. And then you have to think about what does it take to go to pi over 6 from the starting position here on the x-axis, and a little bit of arithmetic, and you get 5 pi over 6. So this, equation like sine of x equals a half, you'd get x equals pi over 6 or 5 pi over 6. Now that's assuming we were given the instruction that our angle should be between, say, 0 and 2 pi, which is generally the guidelines that we have. Or the cosine of x equals -1. You look at your circle and say cosine goes with your x-coordinate, your horizontal coordinate. That's going to be -1 over here on the left side. And the angle that got us there is pi. And of course, that's the only place that is going to have an angle whose cosine is -1 in one trip around the circle. So your angle is pi. So those are the ideas that happen. They usually just happen, though, in somewhat more complicated functions, like maybe something like 2 times the cosine times the sine of an angle plus the sine of an angle is equal to 0. So now the fundamental strategy here again is kind of factor when something is set equal to 0 and then factor it. We can see we have a common factor of sine here, so we can take a sine out, and what would be left would be 2 cosine of x plus 1. Set that equal to 0, and now you're going to say that either the sine is equal to 0 or 2 cosine plus 1 equals 0. So the sine of x equals 0, that's going to think about on our circle the places where the height of our triangle would be 0. So it would be over here on the right side. That angle, of course, is 0. And then on the left side, over at pi. So two answers for this, x equals 0 or pi. And then we can come over here for this, and this is going to be equivalent to 2 cosine of x plus 1 equals 0, or 2 cosine of x equals -1, or the cosine of x equals -1/2. And now again, we just got to know our circle and realize that if the cosine is going to be negative, we're going to be over on the left side because that's our cosine corresponds to the width or the horizontal component of the triangle. So that would be -1. The hypotenuse would be 2. You should recognize that this is going to be √3. Be negative down there, but it would be positive up here. And that reference angle should jump off at you. If I look at that reference angle right there, which is the same as this one down here, that angle is going to be pi over 3. So we're going to have two angles that are going to get us there. 2 pi over 3 here, which is 1/3 of pi less than pi, because here's pi. And if we back up by 1/3, we would be at 2/3, so 2 pi over 3. Or think about going to pi, round to pi, and then going one additional pi over 3, which would be, 3/3 of pi plus 1/3 extra is 4/3 of pi. So we get two solutions. X equals 2 pi over 3 and 4 pi over 3. So for our final answer, we would include all four of these guys. So that's a classic, case, something like that, where you have a common factor, but again, it's set equal to 0. And then the only thing that gets a little bit more interesting than that is maybe something like a 2 sine squared minus a sine minus a 1 equals 0. Again, a factorable expression. Figure out the factoring on it, and we would have something like 2 sine times a sine is going to get us our 2 sine of x. These guys have to be 1s because they have to multiply together to get 1. And finally, we've just got to get the positive negative thing right here. So if we take our outside function, our outside terms, 2 times this 1, and then inside sine times this 1, I think we're going to need a negative to go over here in this guy and a positive here. So that we're going to get a sum total of negative 1 sine x in the middle from our outer and inner terms. So we get two expressions. This guy is going to yield sine of x equals negative 1/2, and this one would yield sine of x equals 1. Think about your circle again. Sine is negative 1/2. That's kind of similar to this example we looked at up here. Sine would be negative 1/2 at the, down here and down here. So we could think about that being 6/6 plus 1 extra sixth, which would be 7/6 of pi. 7 pi over 6. And then the one over in the fourth quadrant, you've stopped 1/6 of pi short of 2 pi. So that would be like 1/6 short of 12/6, which would be 11/6. So we have 11/6 pi here. And now sine equaling positive 1, that's going to be at the top of the circle where we are at 0, 1. And that angle, of course, is pi over 2. So that guy gives us one more solution, pi over 2. So these are the typical kinds of equations that you have to solve using trig. The algebra portion of it is pretty basic. It's just, just like you learned in Algebra 1 with factor, set it equal to 0 and factor. It's just that you need the trig knowledge of the circle to be able to solve these things. Now, all of that was done without a calculator. They were all special angles. If you have a calculator on one of these things, certainly you can do all this work, but you could just certainly graph this guy, and if you're stuck between 0 and 2 pi, just make your x window 0 to 2 pi. Your x min would be 0. X max is 2 pi. It doesn't even matter what you set your x scale at, but just graph it, and whatever the heck it looks like, wherever it hits 0, you just pick those values, and that would do it. Just kind of an interesting problem type that we come across in our study of this trig and the circular functions. Simplify an expression like the cosine of the arc sine of 3/5, which could equivalently be written as cosine of the inverse sine of 3/5. And key to these problems is recognizing what this inner expression really means. That's the angle. Technically, it's an angle between negative pi over 2 and pi over 2, whose sine is 3/5. Okay, so we can think about drawing that and say, okay, well, that angle must be here, and the sine is 3, which means its opposite side is 3 and hypotenuse is 5. So as long as you understand that that's talking about an angle, we could just call that angle theta, and then we're looking for the cosine of that angle, because we just said this whole thing is just an angle. And now we have a picture of that angle, and since we're being asked about its cosine, we just need to figure out the adjacent side so we can put it over 5. And a quick little Pythag, or knowing that it's a 3, 4, 5 triangle, tells you that that's going to be 4. And so the cosine of that angle would be 4/5. So this expression that we started with, the cosine of the arc sine of 3/5, is simply equivalent to 4/5. And you can have fun with that. Just put in all sorts of different trig functions there. You wouldn't want to use the cosine of the arc cosine of 3/5. It's just going to be 3/5. So we're always going to get a mix there. Start with a cosine on the inside and a sine on the outside, or an inverse cosine on the inside and a sine on the outside, something like that. But they're pretty straightforward problems. The key is start drawing a triangle, and then knowing that what this inside expression means. That's basically giving you a picture of an angle with two sides of a right triangle. You'll be asked to find the third, or you need to find the third side to be able to answer this simplification.